Right, can you check the slide?
Yeah, it's like haven't started yet. It just says waiting. I think we just need to. Oh, there we go.
All right, so.
Okay, yeah, it's working.
I can't get out of it. I'm trying to get out.
Oh.
I literally can't.
Oh, what the heck?
It's stuck.
Alt 4?
Oh,
It's he can't not 4. It's like
oh, I got you. What do I do for that?
It's out. There you go.
what?
And him. What did you do?
What? Oh, what did you do?
I don't know. All right. All right. We'll be starting now. Okay. So today we're going to be talking about training and deploying a machine learning model. So this is like the culmination of training your first model. Before we talked about what we're going to be doing at ML Mondays, and then we introduced deep learning. So now we're going to be trying to train one and deploy it. So I'm not going to be going over everything there is to know in this one workshop, but I'll be going over like the main things you'll probably want to know when trying to train a model. And I'll be like basically commentating over me training a model, and in turn y'all also training the model. So that's kind of an overview of what we're going to be doing today. Hope you all enjoy. All right, so I'm just going to start off with a recap of the deep learning stuff we talked about in the last two workshops. So first, we introduced machine learning as a weighted program, kind of like a weighted function. Like programs at the top, they just have their inputs or no input depending on your program, and they have like results or outputs. And for a machine learning model, they have an input and weights, and they have their results or the prediction or output. So it's kind of an overview of the differences between a normal program and a machine learning model. So again, we went over how we pick these weights for our machine learning models. First, I introduced the idea of randomly choosing them to get y'all acquainted with the idea of weights. And then, I showed y'all the idea of adjusting it based on a measurement of error or how wrong it is from the values you want to get. So that's like how you eyeball it and you try to look at the difference, and then you want an error for that. And then we went over how we can use the slope of the loss to know how we adjust these weights automatically. I know I went over it pretty like high level, and we'll probably get more into it later on, like actually coding it up or looking at examples. But that's kind of the idea I went through last time. So, yep. And this is just a picture of like the ideal case where it just gets you the perfect parameters or weights. So just starting this off, anyone have questions about like the stuff I was reviewing? I know I went through it real quick. So any questions about like weights, the general structure, which is like architecture, which is the parameterized function, loss, which is a measurement of error, and optimization, which is automatically picking the parameters. Any questions about those three topics? Okay. All right, so we'll be getting into basically this way. I know I showed this in the first workshop or the second one, and it is training a machine learning model. So if you put everything together, what we went over, we can summarize in this one picture where we are using supervised learning, which is with wins. So we had our inputs, which is our examples or stuff we want to predict stuff on, and then parameters, which was the weights. and our architecture, which is the weighted function or the neural network. And then we predict it, and we see how wrong it is with the loss, and we update. So those are like the three main things about deep learning and like training machine learning models. So, any questions about this idea? Okay. So I wanted to go more into like, let's say you've trained a model and you've kind of got like some good generalization, just meaning it performs well in the task. So what would like these weights or parameters kind of look like if you were to like imagine them? So in an example of like an image detection model, this can be like kind of the idea of some of the features the weights kind of learn. So if you were to visualize like the first layer, it would kind of learn just like very simple features like where are the straight lines, is it bright on one side, is it dark on the other, like kind of here. Like this one over here. And the second layer might combine those different features into more fine-grained features, whereas like one's orange, one's yellow, maybe there's different like color patterns. And then like third layer and like further layers, they have more complex things. Like you can kind of see like a teddy bear in this one, a human, and like honeycomb shapes. So you can kind of see like how the first layers build atop the later layers build atop the prior layers, and they use the features to build more complex like features. Any questions about the idea of like features? Because that's just like what it's learning. Maybe any surprises, like were any of y'all surprised by this sort of way of doing things? Okay. So today I'm going to be talking about transfer learning because when we're training a model and we're training it from scratch, it can take a really long time to train it. So if we went back to the previous slide, in this slide we had like all of these layers and features. It'll take a lot of examples and a lot of time and compute power to get these features and like get these things already done for us. So we're going to be utilizing a technique, it's called transfer learning. So we don't have to go through all that trouble because other people already have done it and they uploaded it online. So why not use it, right? So the idea of transfer learning is, let's say there was a model that was already trained, which is like the top model, like right here. It was trained on some task. And we want to do like, let's say it was trained on like classifying like thousands of different like images into different categories, and we don't want to be like that complex. We just wanted to like detect if there's a bird or not a bird in the picture. So what we can do is, like earlier we had those features, the initial features, those would be important to classifying a bird, but we may not need as much as the later features. So we want to retrain some of it, but we don't want to retrain all of it. So it's kind of the idea of transfer learning where we retrain the network on a different task. And how we do that is we just show examples and go through the process of updating the parameters, like after taking a loss and stuff. So it's kind of the same process as training the original model, but we're just doing it on a different task. I know this can look a bit confusing, there's like a bunch of different things happening. So here we have like frozen weights, which just means I don't want to change the earlier stuff because it's already pretty good. And then I want to retrain the later stuff because that's more task specific. So that's kind of what's happening in this picture. I know this can look a bit complicated. Anyone have questions about what's happening here?
In the fast AI, it's saying that if you do a transfer only, you move the last layer.
Yeah.
Are we going to do that here?
So what we are doing, so yeah, I guess kind of. So in this picture, it's not necessarily shown that we're removing the last layer, but we are retraining all of those layers. Oh, we are retraining all those layers, so the idea is kind of the same. You can remove it, I just don't think the visuals are showing it. But yeah, you're right, we do have to remove the last layer, but that might be a bit too ahead of what we're trying to show right now. Any other questions? Okay. All right. Let's actually get started with the workshop now. We're going to be going through some code, and I'm going to be telling you about how we actually train the model. So, yeah, we're going to be starting a lot earlier than last time. I'm going to have to screen share differently. Give me a second. Just get out your laptops while I'm switching over to the different screen.
Just like, I think stop screen and then maybe like select a different window. Select screen 1, screen 2. No, that's not one. Screen. Okay, where the hell is it? I'm gonna get lucky.
Huh?
Wait, what
All
did
right.
you just do?
What did you want me to do?
No, because like when you switch screens, I could see like the screen that we wanted.
This is so. I'm just trying to
He's
share
trying to
the
share
screen.
like the browser.
On here?
Yeah.
Yes.
It's just
And then you can just go here.
Oh, you can?
Yes.
but it's not showing.
Press
All right,
allow.
cool.
Allow?
Go back.
Let me get out of this.
Check the YouTube.
All right. Sorry about that technical difficulty. We're just trying to make the live stream work well.
It's lagging. You just have to wait.
I mean, it's slow.
Okay.
Just
All right. Yeah.
Keep going.
Okay. So to kind of introduce what we're going to be doing today, we're going to be having y'all go onto Google Colab and run one of these notebooks. So what I want you all to do, you can just follow along on the screen, what I'm doing here. So which one of y'all have a Google account or a Gmail? Okay, so y'all should be good for like today's workshop because we're gonna be using Google Colab. If you don't have Google account or Gmail, hopefully you came to the first workshop and you can do it locally. But yeah, so we're gonna be searching up Google Colab on Google, and it's gonna be like the first link. So just click on the first link, and then this thing should show up. It might be a bit different for y'all, so I'll just wait here till y'all do this. Does it look like y'all? Yeah. Okay, cool. So what you can do now is you can click GitHub right here. It's like the fourth one from the top, and you want to just search up this workshop. I know it's a bit. Oh. Sorry about this. One sec, sorry.
There's nothing on slides. Share screen.
Entire screen.
Nope. I have an idea. This is the mode.
Just 1 second. We're trying to make sure the live stream works on YouTube for people that can't be here.
All right, cool. All right, so I know it's kind of hard to see, but let me just search this up. So you want to go to the GitHub, which is ML Mondays. All right, what's up? In the Discord? Yeah, okay, that's a good idea. Okay. Member chat? Resources? Hey, cool. Oh, I don't have permission. Nice. I'll put in the general chat, okay? Here it is. All right, so just raise your hand if you don't have the link now or you can't find it. You can try typing it in manually, unfortunately. let me add it to this slide down here so it's easier to type. All right, I just want y'all to get the link, so I'll go back to it. Raise your hand if you don't have the link yet. Okay, I'm gonna assume y'all have the link. So what you can do now is you have this GitHub section in the the Google Colab. What you can do is copy this GitHub link and paste it in over here. So just paste it in the GitHub section and you enter the URL. And then I want y'all to press enter and select training and deploying for workshop 4. This one. So did I lose anyone on this step? Just raise your hand. You all good? Okay. All right, so once we clicked on that, it should basically get us into here. All right. So just raise your hand if you're not here. I just clicked on the link. Wait. All right, so how many of y'all did I lose on this step where we got to here? Just raise your hand. Are we good? Just raise your hand if you're good then. A lot of raising. All right, since I think the majority are good, we're gonna continue. And if you're not good, just raise your hand and one of these two will come and help you. Okay. All right, so first thing we need to do is install the dependencies, which is like the first thing. Oh, run anyways. So this is just gonna install the things that we need installed, and then this is just some dependencies. Okay. And I'm just gonna go over what's kind of happening here. I'm gonna zoom in a bit. So first step we're gonna be doing is we're gonna be creating a custom data set. So that just means we're gonna be searching up pictures online and using that as a label. So, All right. So has everyone gotten to this point where we are on the collab? We ran the first 2 cells, which is installing the stuff and importing it in. Still running? Okay, yeah, that's good. That's fine. I'm just gonna go over what we're gonna be having y'all do today. So what I want y'all to do is I'm gonna be following along with a simple example of cat and dog. Y'all can choose like different categories. I actually recommend y'all to choose a different category because y'all get a hang of things doing it differently. So what categories means is what we're gonna be doing is we're gonna be having our script search up these search term, which is dog and cat. It's gonna download images from DuckDuckGo, and that's gonna be our data set. So we're gonna download images and we're gonna make it into a data set, and then we're gonna train a model on it. And eventually we'll have you deploy it. So you guys can just like throw in a picture and get some predictions. So that's gonna be what we're gonna be doing today. And here you need to choose some categories. So some recommendations can be, if you have a lot of pictures of your cousins, you can put that. I don't know why you would do that, but you might want to. You can search up, you can choose like different animals if you want to do that, or different flowers or different plants, whatever you feel like doing. I just recommend y'all choosing a different categories here so y'all can like mess around with it a little more. And then the second thing is you can choose max images. It just is how many images we're going to download and train on. So I'm going to do a bit less because I don't want it to take forever. But I do recommend y'all doing a bit more, maybe later if you have the time. I just do 5. Okay. And so I explained what these two things are. Anyone have questions about what's happening here? Just raise your hand. No? Okay. So the next thing, what we're going to be doing is we're going to be defining an output folder. It's just going to be where the data is going to be saved. And we're just going to be creating the folder if it doesn't exist. And if it exists, it's just going to put stuff inside that folder. What's up? So if you're in Google Colab, it'll be on the cloud. I can show you how to get there. You can just click the folder, and this is where everything will be like saved. But yeah, I'll show you after we have some stuff downloaded. So it's just gonna create the folder if it doesn't exist, and you can check if it's here now. It should be created after you run that cell. Okay. And now this looks a bit complicated, but if you take a chance to read it, what it's doing is just going through the categories that we defined earlier. So there's just gonna be dog and cat. And this thing over here, TQDM, it just like makes it look fancy when you're running it. It has like progress bar. That's all it does. So we have our category and a for loop, and we're gonna be creating a new output file or output folder. It's gonna be the name of our category, so we can easily like find the labels of our images. So it's gonna save all the cat images in the category cat inside the data folder. That's all this means. And it's going to create the folder if it exists, if it doesn't exist, and if it does exist, it's going to be fine. So any questions about what's happening over here where we're just creating a category folder inside of data? Nope. Okay, nice. So next is we're going to be searching up these images. So we got our search term, which is the category, and then we have the max results, which is we defined earlier how many images we want. So it's going to give us search results, and then we need to get the URLs for them. So what you can do is you can print search results just to see how it looks like, and it's just a object or a dictionary. So to get the URLs, you just grab that property from the object or dictionary or the key, whichever one. And then you have a list of URLs. So once we have our list of URLs, we're just going to go ahead and download it. I'm move it up. So we're going to download it, and it's going to download these images, and if it can't download, it's just going to continue. And then after that, after we download those images, we're going to resize them so they're all one size. It's more of a technical thing. I can go over that later on in different workshops. So we're going to be resizing the images after we download them. Any questions about what this complex looking thing is doing? Does it make sense to everyone what's happening here? Okay. So
I clicked on the folder as you said, and then I went back, and then now I can't find the data.
I don't think I told you to click on the folder. You can ask him for help right behind you. Okay, so I just ran this, and it should be running. Yeah, I think in Google Colab it doesn't show the output. So that sucks. What's up?
So you're creating a list of URLs.
Yes.
What is result image? Like the first part.
Resize image?
No. So URLs equals to what is the result?
Sorry. It's just Google Colab. Right. So he's asking what does results and search results mean here?
I mean, search results, I can see it's
Yeah.
essentially downloaded pictures. Right?
Yeah. So search results contains a list of
Okay.
dictionaries or objects, if you're familiar with different
Yeah, no,
languages.
dictionaries.
And each object is going to be stored into result. And we want to take the property image from it, which is the URL.
So is it's dictionary of what?
It's a dictionary of, I guess it'll contain different properties like metadata,
Okay.
search ranking
It's
dates.
essential information about it.
Yeah,
And the picture itself. as well.
yeah, it has a URL of the
Okay.
picture. So we get the search results and then we get the URLs of them from the results dictionary or a result dictionary. And then we go through each URL and download the image. Since this stuff isn't like showing up on Google Colab, I'm gonna quickly switch over to my other one because it'll show up. Maybe it's just my computer or something, but yeah. I'll keep on going here, but when I show you the pictures, you can see it over here. Everything's happening. So there's supposed to be a progress bar. It wasn't showing up on my Google Colab, but that's kind of what's supposed to happen. And then it's downloading it. And then the next step is some of these pictures are going to be downloaded incorrectly. So what we can do is we're going to be removing them by checking which ones aren't working, and it'll build a list of which ones aren't working. And then we're going to go over that list and just remove them. And it will just list which ones have been removed, kind of, like how many have been removed. So, okay. So I hope you all are following along with this. Have y'all like gotten to this part yet? All right, cool. Okay, so before we go into the next bit, I want to get some of y'all to like say which categories you all chose, just to make it a bit interesting. Just raise your hand if you want to share what category you chose.
Dog, fish, cat, and cars.
Okay,
Dandelions and yellow roses.
dandelions and yellow roses, cool. Yeah, I'm just interested in like what other people can choose. I will show you an example of like using like this kind of stuff a bit more creatively than just choosing like raw like categories. That could be interesting. So this is gonna be like the main part, like the setup of this. So the library we're using, it has like something called a data block. It's just like a blueprint for the machine learning model, which it contains basically this structure, but in one function. So that's kind of the data block. So it just contains this big structure in like one class or function. So just to kind of go over what's happening here, we have this data block thing. Think of it like a blueprint for a machine learning model or like training one. And the blocks over here, I'm just trying to give you an understanding of what's kind of happening here. If you don't understand anything too clearly, you can try messing around with yourself on it or just searching it up online. But I'm just trying to give an overview. So blocks kind of here, it just defines what the inputs and the outputs are to the model. The inputs are the images and the outputs are going to be categories. So it's kind of an idea of what's happening there. Any questions about that? Okay, and then get items, it's just telling it how should I like retrieve these images or stuff. So what get image files does is it loads in the URLs for the images, or no, the paths for the images, and it puts it in an array. So that's kind of what get items is doing over here. It's just telling it how to retrieve the data or which things to retrieve. And splitter is going to be splitting the data, which I'll go into in the PowerPoint slides. Okay, so we're back to the PowerPoint slides for now. So training and test split. So to go over a crucial idea in machine learning is training and test split. So I stopped at random splitter, which is a idea of splitting the data such that there's a section that we can actually test the model on, and there's a section it can train on. To kind of make this idea concrete, I'll give an example that we all probably dealt with because we are in school, or we probably have been in school, is homework and a test. So your professors, think of them as like the model structure, and they're trying to basically test if you know a topic. So what they do is they give you homework so you can learn the topic, or lectures to learn the topic, and then they test you on it with the test set. So to make this idea more concrete is, wouldn't it be a bit dumb if they just gave you the test answers before even taking the test? So that's kind of the idea of why you would want to split the data. Go ahead.
For the category that you mentioned, like you just gave cats and dogs, like
Yeah.
Do these categories that we make usually have to be like almost the same thing, or they can be like completely different?
They can be completely different. So I just chose an example that can be pretty simple, everyone can understand it. But I've seen like very creative stuff happen, like where people try to classify like crop yields from images of satellite pictures. And something I did before was try to classify emotions in speech files, where you convert the speech into images and then classify it. Yeah, but that's like kind of like using this tool and using it creatively sort of thing. So to go over the idea of a training and test split is like, if your professor gives you the answers, kind of make it redundant. You already know the answers, right? So it's kind of, it's not a good test, right, of your intelligence on that topic. So that's kind of the idea of a training and test split. So we split the data so we can actually test how well this model knows what it's talking about, basically. And that was the random splitter part of it. So another part is we got to randomize it. And the reasoning behind that one is another slide. Okay. Is think of yourself as the teacher in this scenario and the model as the student. The student, like some of y'all might be or some of y'all might not, is just trying to get the best results with the minimum efforts. And you can think of the model trying to do the same thing, where if you just basically give it the answers, it's just going to use the answers. So what your task as the trainer or the teacher is trying to limit the things and like structuring everything such that the student has to actually know the thing or know how to perform on a task or the concept to pass the test. So a thing that a model could do is they could memorize the order of the answers and just remember the order of the answers. If your answers are always like the same order, and like the last section's always C, and the first section's always A, is gonna memorize that instead of actually knowing the concepts. So that's why we wanna kind of randomly throw the images around so it doesn't learn any patterns like that. Because like if the first 50 images are all cats, the second 50 images are all dogs, it's gonna like figure out that all of them are like kind of split up. And it'll just learn how to classify based on that. So it won't be able to actually perform the task. So that's kind of the idea or the general rule of thumb you want to go by when thinking of a model. Just think of it like a student that wants to do the minimum effort to perform well. Okay. So last thing is we're just gonna get the labels of the images, and the way we stored it on the data set is we just had it in two folders called cat and dog, and it has all the images. So what's happening here is get live just means to label what it's supposed to be, and it's just telling it to get the parent of the image folder. It's just telling it to get the folder which it is in. And then the last one is just resizing it so all of them are the same size. Okay. And then we can just show a batch of examples that our data set has. And it would just label it cats, cats, dogs, and cats. So next step is everything's been pretty abstracted away here. But what we're going to be doing here is we're going to be having a vision learner, which is basically the structure of the whole model and the training routine. And we're going to be using that to fine tune it on a task. So I'm just curious, are y'all all like playing around with the collab notebook or something? Raise your hand if you like ran through all of this already. All right, cool. I just wanted to get an idea of what's like everyone's doing right now. Okay, so the vision learner is basically going to take two things mainly. It's going to be the data loader, which we got from the data blocks, and it's going to take the architecture, which is like the parameterized function, but like formatted a bit differently. We're not going to go too much into this right now, but we'll go into a different workshop. So right now we have a ResNet 18. It just means it's 18 layers, and this special thing called ResNets. We'll go into that in a later workshop. And the metric is what we're going to be, like us as humans, we're going to be looking for, and that'll be the error rate. And it's going to tell us like how wrong it is on the task. So there's a couple of main things here, and that is the ResNet 18, which is the architecture of it. It's just going to say how complex is the model, and how like changing it can result. And then the next thing is learn, not fine tune. Fine tune just means like transfer learn on it. So if we were to just train it normally, it's going to start from completely random parameters. Like here we're using a already trained model. So we're just going to fine tune it. And then we define how many like times you go through the data set, which is 4 times, just for simplicity or time savingness. Just run through that. And it's going to be like throwing out some numbers at us. And we kind of already trained this whole model, and it got an error rate of 0.28, which means like 28% error.
Why do you need to run 4 times?
Okay, so I like to think about it like a student. One time, like for example, when you're learning about a concept, if you know it once, you might improve somewhat, but if you keep on reviewing it over and over, you're going to kind of understand the concepts more deeply, and in a sense, it's doing the same thing.
But the data is identical.
Yeah. So let's say you just go over the same homeworks over and over again, just testing yourself, and you just kind of learn different things after a while, and that's kind of the idea of going through it multiple passes.
Does it don't memorize it? That's
So here what's happening is, sorry to cut you off.
it's the engine don't memorize it.
Okay.
Just go over and over.
So just to kind of show you, the technique we're using to like basically update the parameters is gradient descent, where let's say this was the loss graph. I don't know if everyone can see this, but you might have started over here. So going through it multiple times has you take more steps in the direction of the down path. So the reasoning behind going over it multiple times is, let's say you took one path and you only ended up here. You might want to continue doing it, and it'll take more steps towards the ideal parameters. Yeah, so how you would know is basically based on the error rate and the training loss, which tells us how wrong it is. So training loss can be, we ideally want it to be 0, but sometimes having 0 kind of shows that you've overfit, or like it just memorized it basically. Yeah, yeah. And this framework also has like a feature where we can see what the model basically predicted incorrectly. And this just shows that it predicted a cat, and it was actually a dog. And this is like the probabilities it chose for either one.
So how far will you go down to one error, one error?
So it depends on the situation, but usually it's just up to you. You can train it over and over, try to choose the best model. It depends on what you're trying to do or what your task is. So looking here, the error rate kind of seems small to me, or like it seems a bit too big to me. I'm gonna just try rerunning it to like see if it improves. It got worse. Maybe the model is not that good because it's a bit smaller. So I'll go into another key concept in training models, that is model capacity. So in the last two lectures or two workshops, we introduced the idea of linear and nonlinear functions, and that was to basically increase the model's capacity. I know I haven't talked about model capacity, but I'll talk about it now. So what a model's capacity is just like the range of things it can kind of like estimate. So with just a straight line, the model capacity is going to be low because it can't really model or like approximate very complex things. So on the left, we kind of see something that is very simple model, and it's not really fitting the data correctly. Because here you would ideally want it to be like kind of curved through, and that is when the model capacity is low, it's underfitting. And when the model capacity is too high, where it might have too many layers, it will be overfitting where it just goes through every little point and it just like memorizes the data in a sense. And ideally, you just want to generally go through the ideal structure. So that's kind of the idea of model capacity. And this is like pretty key when you're trying to train something. And a way to kind of see if your model is underfitting or overfitting is by looking at the training loss and the test loss or the validation loss. And how you can kind of see if something is not performing well is if your training loss is going down, but your validation loss is like not going down or it's increasing. It just means that it's just getting good on this, but it might be memorizing it. Okay. So just to kind of show like what the model resulted in here, it's called a confusion matrix. It's just saying that for the cats, it classified 3 cats as cats, and here it classified 2 dogs as dogs, and here it classified 2 dogs as cats. So you can kind of get an idea of what the performance of the model is by this like graph. And I'll quickly go through this. Okay. So yeah, this was an example of like a model or like a picture it saw and it kind of mispredicted. Just to give you an idea of what's happening in the model. And this part is where we're gonna be like going through saving the model and deploying it. So you can like send it to your friends or whatever you wanna do with it. So we're gonna export the model, which we take the learn and then export it and into a name or a path. And you just choose model PKL. And it's gonna be exported. And I made this little class over here. What it just does is it loads in the model. And when you want to predict it, it takes in an image and it predicts on that image which like class it is, or like what is it, like is it a dog or a cat? And it's stored in these things. This is going to contain the actual label, which is a cat or a dog. This is going to contain the index, which is it the first index or the second one? And this is going to be the probabilities. And that's what we want here. And that is because we want to see how much it estimates it as a dog or how much it estimates it as a cat. And then we just return it where it's like cat and then probability and then dog and probability. So yeah. And to basically display this all and like actually have a usable interface, we're using Guardio. And it just takes an image we just define an input and we choose an image, and then we define a label, and it's just gonna be like category. We define an output, which is just gonna be a label, and then we just use our previous thing, which is classifier, and we create the interface. So I'll just run it, and y'all can take a look at it. So once we run that code, we basically have this nice looking interface where we can just like choose an image or upload one. And let's drop one here. I'll just choose this dog image I saved earlier, and we can run our classifier on it. So it'll return us the probability it chose, like it being a dog or a cat. And we can try it on different images. I chose maybe a bit more confusing one, which is a dog cat. Yeah, I guess it figured it out correctly. It's a dog. But yeah, so that's kind of the idea of what's happening here. Just want to see how many of y'all like follow along with what we did so far. Any questions? All right. Cool. So now we're going to be showing y'all how to actually deploy this model. Since we had the interface already, I showed you kind of how we ran through that. Now we just have to take this program and put it on a server that runs it. So what we're going to be doing is I already made a script which just takes this section and this section and puts it into one Python file, which I call it classifier.py right here. So I just took that code from before and put it in this file. So what we're going to do is we're going to take this Python file and upload it to Hugging Face, which is a place where you can like show your UIs and we don't have to pay for it. So it's like pretty nice. So we're going to be taking this classifier file and our model over here, and we're going to be uploading it to Hugging Face. So y'all can have your own custom model and a custom data set, and you can like share links and stuff. Okay, so we're just going to search up Hugging Face. This is going to be the last bit of the workshop today. So I'm going to have y'all like first sign in because it might take a bit and like do your feedback form stuff. So this is going to be the sign in feedback form. The left one's feedback and the right one's signing in, and the code's right below it. What's up? Huh. It says there's no options. Is there a different link? Yeah. All right, any of y'all still trying to sign in and or fill out the feedback form? Oh, you can? Let's say that for everyone. I don't really know what to do. I think he's figuring it out. Okay, I'll just continue on and I'll show you this once he figures out what's happening. But the feedback form should be working though, if you want to fill that out. I'll give you all like 10 seconds for that. Then I'll go back to uploading the model on Hugging Face. So if y'all want to like train a model after this on your own like little data set, you can do that and upload it. So the hard part about this is just going to be creating an account. So the Google form. Oh, that's the sign-in form. He's trying to figure that out. Okay, sorry about that. So what we're gonna do is we're gonna search up Hugging Face, and this is just a place where we can like deploy our model, so we can just send a link to anyone and use it. So we can search up Hugging Face, and we just click on it. I already have an account, but y'all should create an account. Um, I'll just give you like actually, I don't have that much time. So I'll just like go ahead and show you how to do it. So what we're gonna be doing is go to New, and we're gonna be clicking Space. And we're gonna, it's kind of like GitHub where we create a repository. We can just create the name for it, cat dog classifier. Class share, okay. And we can just choose Guardio because that's what I showed y'all earlier. And it can be public. So now we just have to clone this repo. Oh, it should be up. Yeah. Now the sign-in form is available, so maybe try refreshing it or try getting that link again. Sorry about like interrupting y'all.
Same code.
Yeah, it's the same code. Okay. All right, I'm gonna go back to this so we have a bit more time. So what you gotta do here is we just gotta clone the repo, which just means copying this and pasting it in a terminal. And then what we have to do is we gotta move that Python file called classifier, which I showed you earlier, right here. We gotta move it into that folder. And then we just run these commands over here. So it's not that hard. You just add the file and do that. Okay. So I'll just do this real quick. So I'm just switching into the workshop folder. I'm gonna copy this command and I'm gonna run it. So now we have this little folder here. It's really nice. You can just copy this file and paste it in here. And then we also have to copy this model and paste it into this folder. And then we just run these commands. So since we changed the name, it won't be called app.py, it's just called classifier. And we also want to move the model. So we can just change directory, which is change the folder you're in, and change it to the repository folder, whichever you named it, and git add, and then dot for all the files in that folder. And then we can just commit it and copy that command that was there. And then we can copy the last command, which just pushes it to the repo. So I had to log into Hugging Face, but this is what's supposed to be happening. And once you push it over, it should be on Hugging Face. And I'll show you what it'll look like once you do push it over. I just gotta authenticate it for my account. Let's show this one. So, wait, that's the one I just did. We can have this monkey one. Just restart the space. And when you do push it, it's gonna be something like this, where it's trying to start it up. And it'll eventually show that same interface that you had earlier, and it'll be online. And then you can just share the link with anyone you want, or you can just share it with yourself, I guess, and upload pictures and stuff and get classifications. But that's kind of the idea of like training the model, which I kind of ran through. It might have been a bit slow, but we ran through that. And then we ran through actually uploading it online, which is with Hugging Face Spaces. That's kind of what we did today. And that's all for today. Do y'all have any questions or stuff you want to ask about?
So basically, you create a web service.
Yeah, basically. It's gonna be like the same interface we had earlier, but it's gonna be online, so you can just share with anyone. Before it was just locally. And it might take a bit to build, so I'll just let this run, and that's all for like today. And if y'all are good, you can leave if you want.
On your model, PKO.
Yeah,
So if you don't like that,
you can rename it to whatever you want, and if you want to use a different model, you can delete that one, just export a different one, go ahead and do whatever you want. But I just showed you like image classification today. Later on, we'll go more in depth into what's happening here and different tasks like language. I think there's going to be a workshop on using like OpenAI, API, large language models, because that's like the thing. But kind of the idea here. I would just be over here for questions. I think we might need to go outside for that, but yeah. So. All right, so I think this one just started up, but I just clicked on it when it said upload image, and I could select it. Oh, so I ran the last the code set.